Okay, so in this problem, they give us a graph, and we have to come up with the logarithmic function. So let's think about what the pieces are. So the pieces are f of x equals a log base b of x plus c plus d, right? Those are the pieces. That's like the kind of general form that we have for a logarithmic function. Now, they tell us some things. It says find a possible equation for the common logarithm. When they say common, then they're telling us what they want b to be. So we know that it's going to be base 10. We know b is going to equal 10. Okay? All right. We also can see some things from the graph. Like, well, there goes that. But you can see that it's reflected, right? So a normal curve would go like this, you know, something like that, right? Okay, that would be like a normal logarithmic function graph without having any transformations to it. Okay, so we know it's going to reflect about the x-axis. And that means that a is going to be less than 0. We'll just keep that in mind, though. Okay. The other piece of information we have that's really important for us is normally the asymptote is right here at x equals 0, but you can see where the asymptote is. The asymptote's over here. So c must be 2 because it's shifting 2 units to the left. Okay, now we're starting to get somewhere then. So we can say this much. We can say f of x is equal to, and I'm just going to leave it a for now. I know in my heart that a is going to be negative, but I'm just going to leave it that way. Log, I don't have to write the base because it's a common log, and then x plus 2 plus d. Okay? That's what I know so far. So I'm trying to find a and d. I'm going to use points that they give me. So I can see a point right there that is -1, 1. So I'm going to plug that in for x and y, and I'm going to get this. A log, what am I plugging in for x? -1 plus 2 plus d, that's going to equal 1. Okay, that gives me a log 1 plus d equals 1. Now, side note, we can figure out what log of 1 is. That's a common logarithm, right? So say we don't know what that is, make it some variable. I'll just say y. Okay, then you can say 10 to the y equals 1. Well, how do you get a 1 with an exponent and a base of 10? Y would have to be 0. So all of this equals 0. Now that's a property we're going to talk about later, but when the argument is 1, that logarithm is going to be 0. It doesn't really matter what the base is. But now I'm getting then this to be equal to 0. Well, 0 times a is 0, so now I have 0 plus d equals 1, or d equals 1. Okay, so now I'm getting somewhere. Now I know what d is. So I'm going to scroll up a little bit. Now I have the function f of x equals a. I still don't know what a is. Log of x plus 2 plus 1, because I know what d is now. Okay? So I look for another point that I know, and I have one right here. It's 2, -1. So I'm going to plug in, oops, I didn't want to write that. I'm going to plug in my -1 for f of x. You know what? I won't write it that way. I'll do it the way I did the other one. Whoops. A log, and now my x is 2. So I have 2 plus 2 plus 1. Okay? And all of that equals the output, which is -1. All right. So we're almost done. Subtract the 1 from both sides. 2 plus 2 is 4. Okay, and we get that. So now we can solve for a by dividing by log 4. One thing I want to point out is log 4, we know the base is 10, it's a common log. Log 4, that's just a number. You can put that in your calculator. We don't want a decimal approximation here, we want an exact answer, so I'm going to leave it log 4. But you can divide both sides by that. Oops. Let me write it in something you can see. So I get negative 2 divided by log 4. That is all just a number you could put in your calculator. And now I know all the pieces. I know A and B and C and D. So f of x, my function, is going to equal negative 2 over log 4. And like I said, that's just a number. And then I have log, it's a common log, x plus 2. Plus 1. So a little tricky, but some fun pieces and some algebra in there. Kind of pulling off the pieces of the graph that we could use to find those things.